You're welcome to class. Today we are going to be seeing how to find the nth term, sum of n terms, and the sum to infinity of geometric progression. So first, let's see the general geometric progression is given by this sequence: a, ar, a r raised to power 2, a r raised to power 3, and so on and so forth. The a there is our first term, while the r stands for common ratio. So when it comes to GP, we are going to be dividing. That's why we have ratio there. So let's see the formula for the nth term of a GP. The formula for the nth term of a GP is given by u subscript n is equal to a r raised to the power of n minus 1. Okay, the n there is our number of terms. So let's see the first example. If 8, 16, 32, 64 forms a GP, we're asked to find the common ratio and the 8th term. So the common ratio, we are going to be dividing each of those terms by the terms that precedes it, and when we do that, we will get 2. So 16 divided by 8, or 32 divided by 16, or 64 divided by 32, we will still get 2. So let's see how to get the 8th term now. So u subscript 8 will be equal to ar raised to the power of 8 minus 1. 8 minus 1 is 7, as we know. So our a is 8 times our r is 2 raised to power 7. So 2 raised to power 7 is 128, and when we multiply it with 8, we see that our 8th term is equal to 1024. Now let's proceed. Let's see another example, example 2. The first and third terms of a GP are 2 and 2/9 respectively. Find a, the common ratio, b, the 5th term of the GP. So let's see how to do that now. Let's write out what we are giving. Our first term is 2. Our third term, u subscript 3, is equal to 2/9. So let's rewrite our u subscript 3. U subscript 3 will now be written as a raised to power of 8 times r raised to power of 3 minus 1, which is equals to 2/9. So our a is 2, and our r will now be raised to power of 2, which is 3 minus 1, which is 2, equal to 2/9. When we divide both sides by 2, we have r raised to power 2 equals to 1/9. So to get our r, we take the square root of both sides. So our r will be equal to 1/3. Square root of 1 is 1, square root of 9 is 3. Now let's go ahead to see how to get the 5th term now. So our u subscript 5 will be equal to a r raised to power 4. I hope you know where the 4 is coming from. That is 5 minus 1. So our a, which is first term, is 2 times our r is 1/3 raised to the power of 4. So let's simplify further now. So we have 2 times 1 raised to power of 4 is 1/3 raised to power of 4 is 81. So finally we have 2 times 1, which is still 2/81. So the 5th term is 2/81. So when we have 1, 2, 3, 4, so those set of numbers, we call it sequence. But when we now introduce our plus sign between them, we now call it series. So let's see the formula now for the sum of n terms of a GP. So we have 2 sets of formulas there. Now we use the first formula if our common ratio is less than 1, that is a negative number. Now if our common ratio is greater than 1, we use the second formula. So let's see an example that will help us understand those formulas better. Now the question says the third and fourth terms of a GP are -99 and 297 respectively. Find a, the common ratio, b, the first term, c, the sum of the first 5 terms. So let's see how to do that. So we have our formula for calculating the nth term of a GP right there. Our U3, which is the third term, is -99. Our fourth term is 297. So U3 is the same thing as a r raised to power 2, which is given to us as minus 99. So let's call that equation 1. Our fourth term is r raised to power 3, which is given as 297. So let's call that equation 2. So we are going to first get our common ratio, and we are going to do that by dividing equation 2 by equation 1. So we have r raised to power 3 divided by r raised to power 2 is equal to 297 divided by minus 99. And when we simplify that, we have our r to be equals to minus 3. So our common ratio is minus 3. Now to get our first term, we are just going to substitute this value of r into equation 1 and we'll simplify. So let's do that. So we have a open bracket minus 3 raised to power 2, which is equals to minus 99. Minus 3 raised to power 2 is 9. 9 times a is 9a. So we divide both sides by 9. We have our a to be minus 11. So lastly, let's find the sum. Our common ratio is minus 3, which is less than 1. So we are going to use the first formula under the sum. And this is the formula right there. We are just going to substitute each of those values. So a will be equal to our a is minus 11 open bracket 1 minus open bracket minus 3 raised to power, our n is 5, since we are looking for the sum of the first 5 terms, all over 1 minus minus 3. So we have minus 11 open bracket 1 plus 243 all over 4, because minus times minus is plus, so it becomes 1 plus 3, which is 4. So let's simplify the numerator and we divide by 4. We have minus 671. Okay, now let's see lastly on this video sum to infinity of a GP, and it is given by the formula S equal to a over 1 minus r. So the sum to infinity of a geometric progression is given by this formula. So let's see an example now that will help us to apply this formula. We're asked to find the sum to infinity of the GP 6 plus 6 over 10 plus 6 over 100 plus continue infinitely 6 over 1000, 6 over 10,000, like that. So our first term is 6. Our common ratio, which is 6 over 10 divided by 6, which simplifies to 1 over 10. So we've gotten everything we need, just to substitute into the formula now and simplify. So we have 6 over 1 minus 1 over 10. So simplifying further, we have 6 over 1 minus 1 over 10 simplifies to 9 over 10. And when we simplify by removing the division sign, that fraction simplifies to 60 over 9. So our sum to infinity of the GP above is 6 whole number 2 over 3. So right here I have some assessment question just to check your level of understanding of the lesson. So make sure you solve and get everything correctly. Thank you.